All right, we're going to go over slides 75 to 105 today. It's on chemistry. After we're finished with those slides, then you'll have your work for tomorrow. I will give you guys a paper copy. For our learners at home, it'll be on Google Classroom, just like always. For you guys, if you want to do it on Google Classroom, you can. Whichever form you want to go is fine with me. And I won't see those until you get back on Tuesday.
So we can do it any day before
You can. As long as you don't, make sure you call in your attendance or check in on the website before noon tomorrow.
So like, what if you like sign for attendance and not do it? Do you have to do it?
You just have to be sure you check in before noon. Chemistry. Let me find my marker. Chemistry does not change one type of an atom into another. Chemistry does not change the nucleus of an atom. Chemistry is all about how the electrons of atoms interact with the electrons of other atoms. That is the key. How those electrons perform is what makes the difference. There are rules of chemistry which determine which reactions are possible, which reactions require energy, which reactions release energy. Let's start with a basic rule and apply it to our first two elements, hydrogen and helium, which is where we're going to start with today. An atom that is alone with a single electron is not stable. So if it has one electron in its outer energy level, it is not stable. So since it's not stable, what is it going to want to do? Louder, I can't hear. No. It wants to do what? Stay by itself? It wants to join another element that has an electron. Okay? To be stable, an atom needs a certain number of electrons. The first stable number of electrons is 2. So in order for it has to have at least 2 electrons in its outer energy level before it can be before it can be stable, at least 2. 2 electrons together are stable, 1 is not. Keep that, this rule applies to electrons only, not protons or neutrons, only electrons. How many electrons does a hydrogen atom have? How many does hydrogen have? 1? Try that again. Well,
that was correct.
Where did it? I know it's correct. I just couldn't get to show. There it is. Yes.
The B was shown on your head.
Oh, was it? Okay, then. Will an isolated hydrogen atom be stable? Yes, no, it depends, or I need help.
No.
Nope. I agree. How many electrons does a helium atom have?
0.
How many does it have? 2. Very good. Will an isolated helium atom be stable? Yes, no, it depends, or I need help. Michaela, what do you think? She's giving me the shrugged shoulders. She's not sure.
B.
You think it's B?
No, I said I need help with it.
A. It will be stable. Why is it stable then, Michaela? I just told you the answer to that. Why is it stable? Because it has 2 electrons in its outer energy level. Inert elements. As a result of having 2 electrons, helium has nothing to gain from other atoms. Helium does not get involved in chemical reactions. Helium is inert, means it just kind of hangs by itself. It doesn't work with chemical reactions. It doesn't react, and it's just by itself. Hydrogen is not chemically stable since it's a single electron. What is the simplest solution to this problem while keeping the hydrogen electrically neutral. Equal numbers of electrons and protons. Remember, you can't change anything in the nucleus. What could we do? Hydrogen is not chemically stable. How many electrons does it have? Somebody say something. 1. What is the simplest solution to this problem? What does it need then? If it has 1, what does it need? How many does it need? 2. How can we make that happen? We can put a hydrogen together with what? Well, we can put it together with another hydrogen, then we'd have 2. Okay? Because think about it, Izzy, if we put it with helium, how many are we going to have?
We're gonna have 3.
We're going to have 3. Okay? If 2 hydrogen atoms join together, each will share 2 electrons. Each H would look something like we have H2. Each H atom's electrons will have a partner. This hydrogen molecule is still electrically neutral since it has 2 protons and 2 electrons. It is still 2 separate atoms with 2 separate nuclei, but it shares the electrons. This sharing of electrons makes 2 atoms chemically stable, is a type of chemical bond. There are 3 types of bonds: covalent, ionic, and metallic. This type of chemical bond, shared electrons, is called a covalent bond. So covalent, share electrons. Atoms are held together by covalent bonds, are molecules. So let me back up. If they share electrons, it is a covalent bond, and they are stable. With a covalent bond, the sharing of electrons between the atoms bring each atom closer to the number that is stable, the number in an inert atom. In this case, each hydrogen atom, so we're on H2, each hydrogen atom has a share of the same number of electrons as neutral helium, 2. We will be focusing on covalent bonds and molecules now. Ionic and metallic will come later. Hydrogen atoms almost are never found alone. Connor, why are they never found alone? What do you think, Izzy?
Because they're not stable.
They are not stable by themselves. They are always looking to join with something else. They are either bonded with another hydrogen, in that H2 example, to form a hydrogen molecule, or are bonded to some other elements. How else do we typically see hydrogen in nature? Water. Very good, John. H2O. The name for hydrogen molecule is H2. This number 2 means there are 2 atoms of hydrogen. The subscript 2 indicates the number of that type of atom in the molecule. H2 has 2 hydrogen atoms. Covalent bonds. Isabel Gibbs, when do we have covalent bonds? When we do what with electrons? Michael, you got it? Share. Anytime we share electrons, we have covalent bonds. The number of covalent bonds an atom can make depends on how many electrons it is looking to borrow and share from other atoms. Hydrogen is looking for 1 more. So hydrogen can make exactly 1 bond. Two hydrogen atoms forming a chemical bond to form a hydrogen molecule is our first chemical reaction. 2 hydrogens together, we write it as H2. Or better yet, 2 H's, H2. Okay? This is telling you that there are 2 hydrogen atoms. We write that as H2. So if we were going to continue that, H2O, now how many oxygen atoms do I have here? 1. How many hydrogen atoms do I have? 2. Conservation of matter. Okay, this basically means anytime I have a chemical reaction, however much stuff or how much matter I have to begin with, when that chemical reaction is over, I still have the same amount of stuff. I don't lose stuff. It all stays the same. Now remember, in our fire burning scenario, that would only work if I could contain all the smoke, all the ashes. Then my mass would be the same. So you may lose some mass into the air, but you're not really destroying it. It's just going from one place to another place. Chemical equations have coefficients and subscripts. This is a coefficient, this is a subscript. I told you guys for years, I am no math teacher. Math is not my thing. So I use some different terms that I found over the years that makes it easier. I call this the big numbers, and I call these the little numbers. Okay? Now, yes, I know they're called coefficients and subscripts, but when we start balancing chemical equations, I'll say, okay, now, it's a big number 2 or a little number 2. There are only certain things you can do to big 2's and only certain things you can do to little 2's. But just so you know, the real name is coefficient and subscript. Coefficient indicates the number of particles. Subscripts indicate the number of the type of atom in the particle. Normally we don't show those if they are 1, but we have added them to